Welcome to 6.5. Oh, sorry, let me just get my pencil. Welcome to 6.5, interpreting the behavior of accumulation functions involving area. Today we're just going to be talking about, interpreting the behavior of accumulation functions involving area and understanding how they work and their behaviors and just seeing that all laid out so it's easier for us to understand. So the first thing we have to do is understand that accumulation functions are a form of big F of x equals integration of x at a of f of t times d to t, where a is a constant. We also have to recognize that f prime of x equals f prime big F prime of x equals f of x, right? So using this, we can start to understand the behaviors of accumulation functions and start to understand it and kind of put into context. So we can just see the behaviors right now. So the behaviors of accumulation functions. Big F of x is or has basically is increasing when f prime of x, or let me just say it right here, f, sorry, when big F prime of x is bigger than 0 and is decreasing when big F prime of x is less than 0. That kind of makes sense. We understand that since it's bigger than 0, it should be increasing. When it's less than 0, it is decreasing. It would also be true. It would also be increasing if regular f prime of x is bigger than 0, or if regular f prime of x is less than 0. It's the same counterparts. They are the same. And the relative max, we can also see that if f prime of x changes, if f prime of x changes, or big F, I mean, if big F prime x goes from positive to negative, positives to negative, that is a relative max, and the opposite is true. If f prime of x changes from negative to positive, that is a relative min. And for little f prime, it would be the same thing. If f prime of x changes from positive to negative, it would be relative max, and if f prime of x changes from negative to positive, it would be a relative min. Now this is kind of repetitive. It's getting a little repetitive. We can also see if it's concave up, that would mean that big F double prime of x is bigger than 0, and would be concave down if big F double prime of x is less than 0. We can also see that it would be true for small f, or f prime of x is double prime of x is bigger than 0, or f double prime of x is less than 0. It's kind of getting repetitive, and it also includes a point of inflection. If f double prime, or big F double prime, if big F double prime changes signs, that's a point of inflection. Actually, I messed up here. This is actually where I read my notes wrong. This is actually where it deviates. The concavity and points of inflection. It includes big F double primes for big F of x, but only when regular f of x, it only includes the regular prime. If f of x is bigger than 0, then that's concave up. If f of x is less than 0, it's concave down. And if f of x changes signs, then it is a point of inflection. And this just helps us understand the behaviors of 6.5 of accumulation functions that use area. But that's basically everything for 6.5. Yeah, I'll see you in the next one.